All right, so the first step before you start recrystallizing, we're gonna select a solvent to do recrystallization. The selecting solvent is important. With selecting a wrong solvent, you're not gonna get the crystal product. Okay. All right, this is how to select the solvent. Talk about solvent real quick. So, what is the qualification of being a solvent to do recrystallization? Okay. So, for sure, I think you guys will agree with me. One qualification is the solvent must be inert, which means not reacting with anything else in the solution. If it reacts with your compound, you're not gonna get the compound. Your compound just got ruined. Okay, so first thing, the solvent must be inert. Okay, luckily the solvent that we have in the lab, they are most, I would say 90% are inert. Okay, so you guys don't have to worry about it. All right, now the other two properties that are important. Next one, the solvent of choice must be able to dissolve impurities at any temperature. Okay, so the reason behind is because we want to make just your compound recrystallize, get to the solution, and come back to the solid form. Okay, anything else that's not your compound, we want those to stay into the solution, to stay in the solution, no matter how hot or how cold it is. Okay, so basically that solvent must be able to dissolve the impurities at any temperature. All right. Now the next one, all right, and probably the most important one, the solvent of choice must be able to dissolve your compound when it's hot. Now take a look. From the cold solvent, we're gonna heat it up the whole solution. Okay, get everything to dissolve. So your solvent must be able to dissolve your compounds when it's hot, and then not, can or not unable to dissolve the compound as well when it's cold. How come though? Look at the second step, right? From the first step, everything is in the solution, your compound, your impurity, the red dot, those are impurities, all right? And now the second step is we call crystallizing. We'll selectively make just your compound get back to the solid form. So which by cooling, okay? So this is high temperature, this is low temperature. So the solvent that allow your compound to come back to what we call crash out, to come back to the solid form from the solution, must not be able to dissolve your compound when it's cold. Okay. All right. Repeat one more time. So the important properties of recrystallizing solvent: one, not reacting with anything, inert. Okay. Two, dissolve the impurities at any temperature. Dissolve very, very well. Leave the impurity behind into the solution, not going anywhere. Just stay in the solution. All right. But can dissolve the compound when it's hot, not so well when it's cold. So we, in that case, we are able to make just the compound selectively make them come back to the solid form from the solution. Okay, so that's three properties for recrystallizing solvent must have. Okay, all right, I'll give you some example how to select the solvent. Okay, let's take a look right here. Let's say if you have a biphenyl, you want to recrystallize biphenyl. Okay, it's not pure or whatever. We're gonna test because the solubility test. All right, let's see what happened. All right, let's say I have five organic solvent. No, well, not organic. So we have hexane, benzene, ethyl acetate, water, and then ethanol. Okay, here's how you determine which solvent is appropriate for recrystallizing biphenyl. Okay, so you're gonna take all this five solvent, just a little bit, like maybe 1 to 2 milliliter, right? But make sure you take the same amount. Put into the small test tube, all right? And then you're gonna add just small amount. I usually say just a tip of your spatula. Drop that in there, all of them together, and you just shake it, shake it, okay? And see what happens. So right now it's at room temperature. So we consider the room temperature cold. All right. Let's see what happened. Apparently, hexane and benzene can dissolve biphenyl. Ethyl acetate, water, and ethanol cannot dissolve biphenyl at room temperature. Okay, so dissolve and not dissolve. Now, which solvent should not be used for recrystallization? Think about one more time. One property, really important property of a solvent: dissolve compound when it's hot, not so well when it's cold. This is cold. Right now, hexane and benzene can dissolve biphenyl very well, even at room temperature. What it means that if you get dissolved biphenyl to either hexane or benzene, biphenyl will never crash out. We never come back to solid, because hexane and benzene dissolve biphenyl so well. We can do recrystallization with that. So do not take hexane and benzene. Okay. All right, that's room temperature. Next one, we're gonna take just those solvents that are still can dissolve your compound, put into a hot water bath. Okay, so I have a beaker, put water in it, and I put on a hot plate, and just add up, heat up temperature. What happened is, well, we found out that, okay, water and ethanol cannot dissolve your compound, but ethyl acetate can dissolve biphenyl when it's hot. Which solvent should not be used for recrystallization of biphenyl? Well, water and ethanol. Okay, the reason is, one more time, the solvent for recrystallization must be able to dissolve the compound well when it's hot, not so well when it's cold. Now, right now it's hot. Okay, we want to get everything, the impurity, your compound into the solution. If water and ethanol cannot get biphenyl to the solution, don't even have to talk about crystallizing it. You can't get it to the solution. You can't do recrystallization. Okay, and even at high temperature. All right, so water and ethyl acetate, no, only ethyl acetate can. Okay, in this case, if you want to do recrystallization of biphenyl, you take ethyl acetate. This is an example. Okay, all right, so one step, review one more time. Now, the very first step of doing recrystallization is to pick a proper solvent. Okay, be able to dissolve your compound when it's hot, not so well when it's cold, but can dissolve everything else, impurities, at any temperature. All right, that's number one. So in the lab, you're gonna go to the lab and pick a solvent, do solubility tests, and we just use this technique. Just what I told you. Okay. All right. Next video, we're gonna move on to how to dissolve your compound. Once you have the solvent you want, how to dissolve it. Okay. It might be a little bit tricky, but well, I'll let you know how to do it properly. Okay. All right. Move on to the next.